My name is Jakub Huli, and I would like to present to you a couple of mind-bending technologies that really stretch the limit of what we thought was possible and that technology could do for us. Exhibit number one is the programming language Wolfram, which has the mission of making the world computable. Watch the dog. So here we have program in 3 lines of code which imports video as a list of images and then detects the concept of a dog in each of those images and marks the box around the detected dog. And finally we export a new movie with the detected boxes around the dog highlighted in 3 lines of code. I cannot even imagine how much code I would need in some other programming language and how much time I would spend studying different libraries to make it possible, even just loading video as a series of images. So what we see in Wolfram is that it has very, very high level functions such as object recognition. It has very smart and generic functions such as import and export, which can work on essentially anything. They can import a movie as a series of images. They can import and parse CSV and any other thing you might think of. The perhaps most unique thing about Wolfram is that it has built-in knowledge base. There's these entities such as concepts of a dog, but also continents, cities, capitals, and a lot of other stuff which you can use from your programs. And you can combine anything in that language. So you can map image recognition over frames. You could also actually map a function over visual objects. And this is just one tiny example of what Wolfram can do. Here in the top right corner, we have another example here. This is essentially a single line of code which plots rather optimal route through the capitals of Europe and plots that on a map. Interesting part here is this at the top where we have free-form entry saying Europe, capital, cities, coordinates. Wolfram will interpret that and turn that into code which works with entities such as Europe and states and capitals and their properties such as coordinates. We have find shortest tour, which I believe is NP complete. So it surely uses some heuristics, but just a single function which can work on something relatively abstract as city coordinates. And then essentially no code to create a map with the result. And that's just one of few areas where Wolfram can be used. You can't really read it, but here in the top bottom corner you can see number of areas that Wolfram covers, which is machine learning, image processing, chemistry, and plenty others. Exhibit number 2 is the programming platform Rama, which is the mission of making the development of backend systems 100 times more productive. That's not a mistake, 100 times more productive. You can find their blog and read about some proof of that they made. I don't expect you to understand this code, but let me talk about it. So the code here accepts information about user purchases and maintains information about how much each user has spent and an ordered list of the 500 most valuable users. You might see I have a mistake there, I wrote 100 but it's actually 5. And this is a distributed program running on a cluster of computers. I'm in some 19 lines of invocations. I'm sure you could write something similar in similar number of lines if you only care about an in-memory implementation. But once you throw in a database, you suddenly need visibly more code, and your deployment becomes much more complicated. And I'm sure that the scalability of that solution would be nowhere close to Rama. But before I can actually explain what Rama is, it might be good to explain the problem it's trying to solve, which in my view is three things. The first one is impedance mismatch between code and database. That's not only the fact that your code is in completely different language than the one you use to talk to your database, but also the fact that your database and your data is located somewhere far away across the network, and that each database has a very limited data model, and you can only store data and index data in the way it supports. I use at work an SQL database, and I struggle with this constantly. I struggle to get good enough performance. I am not able to get the indices I would like to get for my code to be optimal. The next problem is scalability and availability. So as the volume of data grows, or as you are getting more and more usage in your application, you would like to be able to just throw more hardware in it and scale pretty well, but that's typically not the case. And if you become really successful, then you need a lot of hardware and perhaps thousands of engineers to keep it running. And the final problem is that nowadays technological solution is essentially a pile of different technologies held together by duct tape. Rama is as if a programmable database and a computational cluster had a baby with Rich Hickey as its godfather. What Rama gives you is a cluster where each node stores part of your data. The data is partitioned and replicated for availability. And you write a distributed program which runs on these nodes. So your code runs on the same node where your data is, and it runs on number of nodes in parallel and moves from node to node to get to the data it needs, and intermediate results are moving with the code. If we take a step back and look at the software architecture of this, so at the entrance of the system, we have an append-only immutable log. Here comes Rich Hickey, which also he comes also in the computation and storage being collocated, right? And then your distributed ETL process runs, reacts to that incoming data and turns that into stored data. What you store here, that's essentially your indices, right? And here we touch on the programmable part, because these indices can be in any shape you might imagine. It could be simple key value, it could be from a key to a whole document, it could be something reminiscent of a relational database or columnar store, or just anything which makes sense for your use case. And most likely you will use number of different indices with different shapes to satisfy all the queries that you care about. And since one of the goals of Rama is to provide you an all-in-one solution so that you don't need this pile of technologies, it also comes with tools for deploying your code to this cluster and scaling parts of the processing and monitoring the cluster and your code. The side of this kind of physical part of Rama, what it also is and or provides is a new programming language with a new paradigm, because what you write here is distributed programs, right? Programs that run a number of nodes in parallel, but also jump from node to node, take their data with them, so on. And this is really hard. So having dedicated language for that makes sense. One of the really interesting innovations in the Rama as a programming language is this generalization of function, something they call fragment. You could call it super function. While normal function you call it and it returns a value. In super function it can emit 0 times, once, many times, and it can emit to different channels. So instead of thinking of your program as a tree of function calls, it's more like a tree, or actually a graph of nodes that react to data and send data downstream. So here we see one index, that's simple key value store, that's user ID to total spend. And here's another index, just a list of things. It's actually pairs of user ID and the total spend. So that's enough about Rama. Exhibit number 3 is electric closure, which is another, you could say, superset of closure. So what we see here on this page is a full stack application which in your browser lists Java system properties from the server, and you get an input where you can write a filter, and as you type, the value of that filter is being sent to the backend, the search is rerun, and you get updates displayed in your front end. Electric closure comes with a compiler, so it will take this full stack program and will split that into JavaScript bundle and the closure bundle. In your code you use these markers such as eServer to make it clear when necessary at which side that part of the code needs to run. So and you see they are highlighted here. So every time the background color changes, that means there is also network communication which Electric handles for you. And Electric is reactive. So these are not just values, the search here and the system props, they are kind of streams of, or signals actually is the proper term, I believe. So when search changes, that is propagated to the backend, this thing is rerun, we get data back, and data back is not the whole result, it's only what changed since the last one. Right? And then this thing is also rerun, and the table is re-rendered and so on. So it's really fascinating. So what I want you to take away from this is look outside of your programming tool, your programming box. There are really amazing tools, and the technology can do much more for us than we are asking it for. So go and look for those tools. Thank you.